Next one, any isomer which can be obtained from or converted into glyceraldehyde with the most oxidized carbon at the top and reduced carbon at bottom, but having OH group at the left side, that is called L isomer. Okay, so same thing, any isomer which can be obtained from or converted into glyceraldehyde. So here D, this is L, glyceraldehyde with the most oxidized carbon at the top and most reduced carbon at bottom and having OH group at the left side is called L isomer. Okay, so D isomer, L isomer. For example, lactic acid. Okay, so here we can give example lactic acid. Okay, so let us see lactic acid. Okay, basing upon that we can give two isomeric forms for lactic acid. Okay, so lactic acid. So this is lactic acid. So we can draw two forms here. So most oxidized carbon in the form of carboxylic acid is pressed at top and reduced carbon at the bottom. And OH group that is present at the right hand side. So we can give D form for this. But it is levorotatory, D minus lactic acid. Okay, so already know that D, capital D and capital L, they shows only relative configuration but not the rotation. Okay, so capital D may be in dextrorotatory and also levorotatory. Okay, capital L may be dextrorotatory or levorotatory. So here this is L plus lactic acid. Plus here indicates dextrorotatory. Minus indicates levorotatory. Okay. So D configuration is levo and L configuration is dextro. Okay. Next, erythro and trio. Okay, we can give dextro about D and L notation for glucose and fructose also. Okay, same examples can be given to glucose and fructose. So another examples. D and L glucose and D and L fructose. So that is purely basing upon the structure of OH group. If OH group is present at the right hand side, so that is D. Left hand side L. Okay. So D and L notation that is applicable for carbohydrates, glucose and fructose. These are carbohydrates and also amino acids. Okay. Mainly. So application of D and L notation for these compounds mostly. Okay. Next, erythro and trio configuration. Erythro and trio configuration. So erythro configuration, if same substances, same groups in Fischer projection formula are present at the same side, that is erythro isomer. Opposite side, that is trio isomer. Okay. So if same groups in Fisher projection formula are present at the same side is called erythro, or opposite side is called isomer. So erythroisomer, same groups are present at the same side. If same groups are present at the opposite side, so that is isomer. Okay. For example, so if you take (2, 3) dihydroxy butanoic acid. Okay, 2, 3 dihydroxy butanoic acid. Here OH groups are present at the same side. So that's why we can give erythro to this. Okay. Then same compound 2, 3 dihydroxy butanoic acid. OH groups are present at the opposite side. Same groups are present at the opposite side. And this is 3O. Okay. Erythro having same groups at the same side, and 3O having same groups at the opposite side. Okay. So this is erythro and 3O configuration. Next, coming to optical activity. Next, optical isomerism. Okay, optical isomerism. So before going to this, first let us know what is plane polarized light and what are the optically active substances, optical activity, enantiomers, diastereomers. Okay, so different terms which are related in optical isomerism. Okay, so first come to plane polarized light. So you know that ordinary light, so that is in the form of electromagnetic waves, which having different wavelengths and vibrates in different directions. Okay, when ordinary light passes through nickel prism, which is made up of calcite. Calcite means that is one of the crystalline form of calcium carbonate. Okay, so this is called nickel prism, and this is ordinary light. Okay, so it is passed through nickel prism, and we get plane polarized light where it vibrates in a single plane. Okay, so ordinary light, this is here the waves, they having different wavelengths and they vibrates in different directions. Okay, so this light is passed through nickel prism, which is made up of calcite. Okay, we get plane polarized light, and it vibrates in a single plane. Okay, plane polarized light that vibrates in a single plane. So plane polarized light, so that is a light which vibrates in single plane. Okay, so light which vibrates in single plane is called plane polarized light. Okay, So next